All right, continuing on then. We are going to now move into a secondary portion of our epithelial tissue, which is fingerprint forensics. So unfortunately, this would have been the lab we were going to be doing, but we just, due to weather and everything else, I decided to call the audible and we'll have a makeup assignment for this instead. So fingerprint analysis is one of the biggest things that we still turn to as far as at least lifting prints, because sometimes those prints often leave other surrounding epithelial tissue that we may be able to use aside from just the print and basing it against the database to be able to say something about, again, that DNA analysis. So things that we are looking for. We are looking through and understanding that fingerprint analysis is an important metric because of the fact that it is unique. No two fingerprints are the same. We're going to talk a little bit about how this becomes maybe problematic in the aspect of same individual. Formation, how these are formed is actually, if you've never thought about how or where this comes from, your friction lines, these little ridges that we see here, right? These are made in utero. So as your skin, right, and as you are laying down these tissues, as that dermis and epidermal layers are being laid down, that epidermal layer is surrounded in amniotic fluid, right? And the way that it happens is it's actually pushing up faster than can be laid down. So when that's occurring, because cells are just being laid down at such a rapid rate to grow you in that 9-month period, it actually buckles, it folds over on itself, and this becomes extremely unique just to you. So of course, we know fingerprints are one of the more reliable, if not one of the most reliable methods of personal identification if the person is in the system, if we have a base analysis for this. So what do I mean? I have put in 2 really cool videos. So one shows you exactly what I was just talking about, kind of how and where fingerprints come from. So you have to be in presentation mode to be able to physically view this, but it's pretty cool. It's just a little bit of a background video I thought was pretty interesting. And then the secondary one that I've put in just for fun is a great TED Talk that talks about what your fingerprints actually show you, what they can tell you about, again, who you are, your exposures to different elements, exposures to different environmental factors, what you're putting into your body, your overall health. This is really important. It is stuff that is starting to be pulled over into forensics, but I just thought this was also pretty interesting if you wanted to give it a check. So the foundation for its acceptance of utilizing fingerprint analysis in court is that, again, we know this is an extremely unique feature. So the probability that 2 fingerprints could match is an extremely low probability, something estimated about 64 billion different individual prints. Hold tight on that. In the past 90 years, the FBI central system, no 2 prints have ever come up as being identical. There's a problem with this just because of the fact, and I want you guys to for sure watch this one. This talks about the fact that our fingerprints in between our individual digits, meaning my thumbprint from my, my index finger and so on, these are uniquely different. So not intra-person fingerprints, these are not unique. So this becomes extremely challenging when you think about it. If I, am dealing with an individual that maybe I have in the system, their thumbprint, or I have their, a couple of their prints, but I don't have all of their prints. And maybe somebody touches, at a very unique angle on a table or a lamp or a doorknob or a weapon, right? this can become extremely complicated. So what would I want you to know about this as far as the exam is concerned? That yes, while our fingerprints are unique, meaning every person has their own unique set of fingerprints. That's the important part. You have a unique set of fingerprints, right? This is why whenever you are taken in, or if you watch police shows, they take all 10 of your fingerprints. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And they base compare them because even your pinkies, right? They can be different. These can be different, right? So this becomes complicated. So yes, while the foundation of this is still correct, each individual will have their own unique set of fingerprints. Intra-person fingerprints, meaning between the individual digits of your hand, right? These are not unique, meaning they can showcase something different, or they can showcase the same, right? There might be some similar patterns here. So this is challenging, is all I'm trying to get at, is that fingerprints within one person versus fingerprints outside of, right? These are unique versus compared to another individual. So what am I looking at as I am taking these observations? I am looking at dermatoglyphics, right? I'm looking at the derma, right? And I'm looking at, the digits, and I'm looking at the overall arrangement and the patterns inside of those physical prints. So we can divide these into 3 major classes: the loops, whorls, and arches. So if I was to ask you a question, based around the population distribution, what we tend to see from the book is that 60 to 65% of the population have this sort of looping pattern, right? 30 to 35% are going to have these whorls, and very few have what's called an arch, which is a one-way in and a one-way out, right? The whirling and the doubling or the looping, it means it's folding back on itself, right? And kind of watching that video about how fingerprints are formed, it would make sense that most of the population is going to fall into a loop or a whorl. So individuality, again, is not determined by the shape or the pattern, but it's determined by what's called the miniature or the ridge characteristics. So again, going in and looking at the different arrangements of the characteristics, not just saying like, oh, that person has an arch or that person has a whorl, right? It's looking at the individual characteristics of depth, of width, of raises, right? Because again, in that pattern, you're creating kind of bumps and grooves, you're creating voids for you to be able to collect that. So again, that's important because those are the miniatures or ridge characteristics that we're going to be identifying. Again, identity, the number and the relative location of the characteristics, the spacing, how many left loops do I have, or whorls do I have? How many of these unique spacing patterns do I have? That is what's being utilized to boil down to creating this individuality of comparative analysis that then goes to court. So as far as dermatoglyphics, which is, again, identifying the characteristics, those miniatures inside of the print, we also have to look at the types of prints that can be left behind at a scene, or when we are trying to even lift prints from a potential suspect, right? We've seen it always in those crime cases where, a cigarette's left behind, or they're at a public place and they touch the beer bottle. Yeah, absolutely, right? If I'm going to do some analysis, right, and we're in a public space, that could be potentially obtained. So I am looking for 3 different types of fingerprints. These can be patent prints, which these are visible or create contact with the material, creating a visible print that one can see. They can also be that maybe I touched a substance And that substance, just like fingerprint ink, now I touch something else and it leaves a physical print, right? Something like blood would be a great example. Plastic prints, these are things that are made as like a 3D image into something. So something that tends to be on the softer side. Putty is a pretty, standard example of this. And then there is the latent prints. These are prints that are left behind that are invisible, but we're relying on the sweat and the oils that are part of that residue, is part of that keratinization that helps, in the shedding of process, that we're going to rely on those chemical characteristics of the print to be able to come in with a secondary mechanism to be able to visualize this, right? And so there are lots of different things we can use. Now we can use even things like, UV to be able to, not only if you come into the station and you need to get prints taken, right? Most of the time now they'll actually use like a 3D scanner that sort of just looks ultraviolet. And there are also ultraviolet mechanisms that we can utilize out on scene. So for the purposes here for exam, I really liked this particular graph that I found, or I should say this table that I found. But the three major ones are really, nihydrin is going to be the major one that we are utilizing. It uses just basically paper. We would have done this in lab. You're going to, dip or spray whatever print you're potentially hoping to reveal, and you're going to wait probably 24 hours, right? What you're relying on is the reaction of the amino acids in the sweat, and what it will produce is this sort of purple bluish print that then you can take pictures of, and you can go ahead and transition over to the dermatoglyphics, right? You can look at the sort of miniatures. Silver nitrate is another one. You are using things like wood and styrofoam. You are, meaning you can remove, let me just say this. You are utilizing silver nitrate on things like wood and styrofoam. Let me make that more clear with the 900. Things like paper is what you would be spraying this on. So you're going to, spray over the silver nitrate. You're going to then wait for the chemical reaction to occur. So the chloride salt inside of your sweat is going to combine with the silver nitrate, and it's going to form silver chloride that can then be visualized. It will come up a black or a reddish brown color under UV light, right? We also can use iodine fuming. So again, this is for things like paper, cardboard, or unpainted surfaces. So you would we would have done this inside of, again, the lab. You put this inside of a little tent, a little makeshift tent, and you are allowing for basically the iodine to be, it's sort of kind of like vaporized, it's fumed into the air, and that iodine crystallization will form and bind with the carbohydrates that are inside of the print. And again, it will form a print that is a brownish color, but you have to photograph it really, really, really quickly, because the second you remove the container that it's in, right, which is keeping those fumes trapped, and now you allow for diffusion, right, of those molecules to go out and play with other molecules in the air, that iodine will jump off. It will remove itself from the carbohydrate. So you have to take a picture pretty quickly. I am not going to worry about the vaporization of this, so don't worry about that. It's 9-hydrin, silver nitrate, and iodine fuming that I would be concerned with. I also put this cool video in. This talks about different ways that we can also lift. So very simply, we can absolutely use just powders, right? And that would have been the simplest. We would have just been using an actual powder, and the metal shavings bind into kind of like the lead inside of pencil, right? It's exactly what it is. You're just shaking it over there, and then you basically apply a little bit of a magnet, and the magnet helps to arrange and falls into those cracks, right? And just like if you played with the Mr. whatever it was to create the shavings around the face and the beard, you can move those and eventually you can shake off, because once the metal shavings inside of the lead bind to the carbohydrate, it's stuck, right? The rest of it will stay where it needs to be, and the rest of it you can shake away, and you can then take a visualization of it. So for our purposes, as far as the database systems, we use the FBI database systems, but if we're looking kind of more on a global scale, we're looking at the IFS, which is the Integrated Automated Fingerprint Identification System. I'm sure you could imagine that would be a great question to ask. But there are challenges with this. As you can see over here, I have, again, one of those more updated ones called Live Scan. And so again, you can, now we're not even going to just the standardization of where we see maybe the prints that are rolling in ink. We'll actually put it onto almost like a bio copier, so to speak. So this kind of live scan report. But prints come with their own challenges like everything else. So prints may be smeared. They may be too poor of quality. They may have been degraded. Again, latent prints, if I don't know what to look for, if I don't know that they're there, or now I'm trying to obtain maybe prints from a scene that I may have missed in the past, time may have passed enough that they may be degraded and I can't recover a clear print at that moment. There is no standardization as of right now for aging of prints. So again, going back to the second point, if I can't say, oh, this print was put down 3 days ago versus 3 weeks ago versus 3 years ago. There's no specific, true metric for that as of right now, which would be extremely helpful, right? It would put people at places and times accordingly. Again, technology limitations, there's biometric security, which can be fooled. Tests have shown that printed fingerprints can trick scanners. So I'm sure we've watched Bond movies or Mission Impossible movies where they've put over another, digital copy of a fingerprint. That can trick the system sometimes. And unfortunately, we're humans. Those that are doing the expert analysis of these things can be flawed. There were studies that were done back in the mid-2000s that revealed individuals who had testified on one case on behalf of something were given the same sets of prints that they testified on behalf of, whether that was innocence or guilt for whoever they testified on behalf of, were given the same exact sets of prints and gave a totally different narrative of whether or not it matched or it didn't. So again, that's challenging, right? This is where things like AI and our biometric systems can hopefully overcome human error. So other prints can include things like our palms, our footprints, our lips. These can all provide ridge identification and ridge lines. So these are all places that we absolutely can do pretty much the exact same type of lifting that we saw in the previous examples of revealing of our latent prints or identification. All of those can be used because they're made of all of the same types of tissue. You know that this exists because you have a phone, and now we have facial recognition for just about everything. What are they doing? They're actually relying on your retina. They are going back to the blood pattern distribution in the back of your eye. And what they're looking for is that you have a very unique distribution to your blood vasculature in the back of your eye as you were forming in utero. Again, that is now a safety feature through an eye scan that says, nope, that is Dr. Varga versus somebody else. And again, that's important, right? All sorts of different variations that we use this. We even do this to open up our bank account statements at this point, right? Pay bills online. So it's definitely a very verified safety metric for unique identification. So Algorithms, two people sharing similar iris characteristics are about 1 in 7 billion. It's not absolutely impossible. It doesn't mean that you couldn't fool, and maybe things like identical twins could come into play here. So there's not a clear understanding of how iris and retinal scan characteristics change after death. This still needs some work, right? Very different than what we're talking about as far as the distribution and the breakdown of the vitreous humor, right? That's not the same. We're talking about that retinal distribution and, you know, scanning of individuals for identification after death. All right, the last couple of places are moving now away from, you know, just simply the dermal layers. And we're looking at things or with inside of the eyes. Now we're moving to things like hair. Hair is absolutely a really good forensic indicator because, again, we're relying on something that is very resistant to decay. Keratin does not break down very as easily. And in fact, most animals on planet Earth cannot break down hair. There's always the misnomer of like, oh, you can feed the, you know, bodies to the to the pigs. The pigs will digest them. Pigs don't really want to eat you. They want to eat pretty much everything else but you. And they will really only turn to that in extremely dire situations of like starvation. And they're not really good at breaking it all down anyway, especially teeth and hair. Those things are going to pass through most animal systems and not be broken down. They're very resistant to decay. So where they are important is that they contain DNA inside of the root. That is the portion of the hair, not the entire length of the hair. It is the root portion, and I'll show you a picture to come. And we can also look at things like mitochondrial analysis if the root is absent. These can reveal lots of things: drug use, poisoning, and even environmental exposure as it relates to where the person might have been, or again, drug usage or toxicity. So that brings me to the secondary 20 minutes of the lecture, and I will wrap it up with the final series of slides in the next video.